Hi, hello, my dear students. How are you all? Good morning to one and all. This video lesson module number 5 on metals and non-metals brought to you by Vignan Global Gen Schools, Hyderabad. I, myself, Reddy.P, Teaching Faculty, Vignan, Madinaguda. Dear students, in the previous module, we have learnt about how do metals reacts with non-metals, what is meant by ionic bond, what are the best examples for ionic compounds, what are ionic compounds, and we even see the formations of sodium chloride, magnesium chloride. Okay, and I already assigned some work for you on the basis of these ionic compounds. So how many of you finished this work, my dear students? At least tell me what work I assigned yesterday and means in previous module. So I asked you to complete formation of sodium oxide, formation of magnesium oxide, and formation of calcium oxide through electron transfer method. Okay, and these are called electron dot structures. So how many of you finished this work? Yes, very good. And few members didn't. Why? Okay, do you want any clarity, like 1 or 2 molecules? Shall I explain? Can anybody want me explain at least 2 molecules out of these 3? Yes. Okay, no problem, no issue. So today actually this particular module is meant for properties of ionic compounds. For what? Properties of ionic compounds. But before, let me explain these yesterday's work, 2 examples, 2 formations. Okay. Now, let me take first formation. What is the molecule given? So some of the students asked to derive this particular formation. What is that? Sodium oxide. Okay, na? Sodium oxide. Yes. Sodium oxide. What is the formula? Na2O. In this sodium oxide, there are 2 ions. One is sodium plus, second one is O minus 2. Because elements are 2. Sodium element, oxygen element. Sodium element contributes Na plus ion. Oxygen element contributes O minus 2 ion. Okay. Now, first let me take sodium. What is the atomic number of sodium? 11. What is the electronic configuration? 2, 8, 1. KLM. This sodium would lose 1 electron from the valency shell to form Na plus, where the configuration become 281 KLM. Sorry, 28 KL. And the nearest noble gas is neon. In that way, sodium attained stability. Okay. Then what about oxygen? Oxygen. Atomic number 8. Configuration 2, 6 KL. This already 6 electrons are there in the valence shell. So to attain stability, still it required 2 more electrons. So plus 2 electrons, O minus 2, configuration become 282. The nearest noble gas is neon. And as I told yesterday's module or previous module, 3rd step is so crucial. What is that? Electron dot structures. And according to that step number 3, this is first step, this is second step. Now according to this step number 3, there are 2 sodium atoms in the molecule. Yes, sodium 1, because Na2 no, Na1, Na2. Each and every sodium would follow 1 1 dot. Yes, why 1 dot 1 dot? Because sodium valence electrons are 1. That 1 valence electrons can decide the chemical properties. And that 1 valence electron we are taking in the form of 1 dot. Okay, according to Lewis dot structures. Now what is the second element? Oxygen. How many crosses are present in oxygen? Since it consisting of 6 valence electrons, so 4, 5, 6 gives rise to. In this case, sodium would donate this electron to oxygen, and this sodium also donate electron to oxygen. So at a time, sodium is able to form Na plus oxygen would gain 2 electrons directly. Then, so 2 dots, first dot from first sodium, second dot from second sodium, remaining 6 crosses as usual, and attained nearest noble gas configuration -1. Sorry, -2. In this way, finally Na plus O minus 2 repeated regularly to form sodium oxide. Yes, sodium oxide molecule. So this is about the formation of sodium oxide. Now let me take one more example from the yesterday's discussion. Calcium oxide. Calcium oxide. What is the formula? CaO. Yes, calcium oxide, CaO. Same. Now first let me take first step, calcium. Electronic configuration 2881. Since atomic number is 20. And how many shells are there? 4 shells. In the last shell, 2 valence electrons are there. 2882. 2 valence electrons. This calcium would lose these 2 electrons for the sake of stability, and Ca become Ca plus 2. Configuration become 288. KLM, and the nearest noble gas is argon. So Ca plus 2 is stable, Ca is unstable. Okay, so calcium is able to form dipositive calcium ion. And now second step, same, oxygen, copy paste. Oxygen, atomic number 8, configuration 2, 6, Kl. Still this oxygen would require 2 more electrons, so that configuration become O minus 2, 2, 8. The nearest noble gas is neon. Okay, so these first two steps are clear. So calcium attained Ca plus 2, O attained O minus 2. Then third step is so crucial, Lewis dot structure or electron dot structure. So calcium would take how many dots, my dear students? 2 dots. Why 2 dots? Because in the valence shell of calcium there are 2 valence electrons. These 2 valence electrons are available in the form of 2 dots. Why you prefer only valence electrons? Because you know that chemical properties of any atom can be decided by valency electrons. Okay, and now coming to oxygen. As usual, oxygen consisting of 6 valence electrons, that is available in the form of 6 crosses. In this case, how electrons transferred from calcium to oxygen? So your requirement is to losing of 2 electrons. So calcium donate these 2 valence electrons to oxygen, so that calcium is able to attain Ca plus 2 configuration. Plus oxygen at a time would gain these 2 electrons and finally become O minus 2. These are the oppositely charged particles. A strong force of attraction exists between Ca plus 2 and O minus 2. That bond is called ionic bond. Because of this bond, finally we will get calcium oxide. So these are the 2 molecules out of 3 what I assigned as a work for you yesterday. Okay. In the same way, you can even do magnesium oxide also on your own way. Okay, now my dear students. So for every formation, how many steps are there? 3 steps. First step is meant for cation formation. Second step is meant for anion formation. Third step is so crucial, which is very important, electron dot structures, Lewis dot representation. So these representations are based on only valence electrons, because valence electrons can decide chemical properties. So this is about two examples from that assignment. Okay, now? So in today's class, let us learn more information about properties of ionic compounds. Okay, na? First of all, what are ionic compounds, my dear students? What is the topic? Properties of, yes, properties of ionic compounds. Properties of ionic compounds. Okay. First of all, what are ionic compounds, my dear students? Yes, you are correct. The compounds formed due to transfer of electrons from metal to non-metal. Can you tell few examples for ionic compounds? Properties of ionic compounds. Ionic compounds are also called, yes, correct, electrovalent compounds. Can you give few examples for these compounds? The very first best example is common salt, sodium chloride, magnesium chloride, potassium chloride, etc. All these are ionic compounds. Okay. Now if you observe these compounds naturally, and we are going to discuss about few properties. All these ionic compounds would exhibit some properties, will possess some properties that we are going to discuss now. Now, what is the first property of ionic compound? Physical nature. What is that? Physical nature. So, what is the physical nature of all ionic compounds? All ionic compounds are crystalline solids. Crystalline solids at room temperature with perfect shape and structure. So my dear students, what is the first property? All ionic compounds are crystalline solids at room temperature with perfect shape and structure. Okay, and these compounds are brittle. You know what is the meaning of brittle? Brittle means easily breakable. So these compounds are brittle in nature and break down into pieces if you apply some force or pressure. Okay, for suppose, let me take this chalk piece as sodium chloride crystal. So whenever if I apply force or pressure on the sodium chloride crystal, this crystal, automatically what happened? This break down into small pieces, and that tells about these are brittle in nature. My dear students, do you know the reason for this structure? Yes, you are correct. Why these are crystalline solids and with some hardness? Crystalline solids and hard. Why these are hard? That is due to strong force of attraction between positively charged ion and negatively charged ion. Since these compounds are formed due to positively charged ions and negatively charged ions, no? In between these two ions, there exists a strong force of attraction. That's why these compounds possess crystalline structure and hard also. Now coming to second property, melting points and boiling points. Melting points and boiling points. Tell me. All ionic compounds are having high melting points, high, melting points and boiling points. Why? So these compounds are having high melting points and boiling points. What is the reason? Now if you take suppose if you take sodium chloride, the melting point of sodium chloride is around 800 degrees Celsius and the boiling point is around 1400 degrees Celsius. Why this much high melting and boiling points for these compounds? Yes, you are correct. This melting and boiling points are due to strong ionic forces of attraction. So, considerable amount of energy required to break the strong inter-ionic force of attraction. That's why ionic compounds are having high melting and boiling points. So, okay. So, what is the main reason for this? Due to strong inter-ionic force of attraction and required more amount of energy to break the bond or break this inter-ionic attraction. That's why these compounds possess high melting and boiling points. Now, third one about solubility. Yes. What about solubility? All these ionic compounds are able to dissolve in water. They are able to soluble in water, are able to dissolve in water. Because water is a what type of solvent? It is a polar solvent. It is a polar solvent. And these compounds are unable to dissolve in kerosene, petrol, benzene, ether, carbon tetrachloride. Once again, these compounds are able to soluble in water, unable to dissolve in kerosene, petrol, benzene, ether, carbon tetrachloride, etc. But how you are going to explain this property about solubility? Very simple. Let me take one example. One of the best ionic compound is sodium chloride. Yes. Let me add this to water. Let's say 5 grams of sodium chloride added to water. What is your observation? Now, at the time after adding some salt to water, water has the ability to dissociate the strong bond between sodium and chlorine. Whenever if this bond is dissociated, Na become Na plus, Cl become Cl minus. And even H2 also split up into H plus and OH minus. That's why water is called polar solvent. Solvent means it can dissolve something. Yes. But why it is called polar solvent? Polar means two poles. Positive pole, negative pole. So, in water, H plus is there as positive pole and OH minus is there as negative pole. And Na plus is migrated towards OH minus, whereas H plus is migrated towards Cl minus. In that way, like dissolves in like. And that is mainly because of this polar nature of this water. And water has high dielectric constant. Water has a high dielectric constant. Because of this high dielectric constant value, it has the ability to dissociate the bond or the force of attraction between Na plus and Cl minus. And finally, these compounds are able to dissolve in water. Water is a polar solvent. So, this is about solubility. Now, coming to electrical conductivity. Conduction of electricity or electrical conductivity. Tell me. Now, let me explain about conduction of electricity. For suppose, let me take two things. One is sodium chloride crystal, sodium chloride salt, and sodium chloride solution. So in these two hands, what are they? Sodium chloride crystal, sodium chloride solid crystals, and sodium chloride aqueous solution. In these two, in which case they are capable to conduct electricity, my dear students? Yes, you are correct. Aqueous solution of sodium chloride is able to conduct electricity. What is the reason? Due to the presence and movement of ions. So, aqueous solution of sodium chloride conduct electricity due to the presence and movement of ions. Okay? So, for the conduction of electricity, you required ions. What are ions? Charged particles, because they are free to move and able to conduct electricity. Whereas in solid state, sodium chloride, salt in solid state, solid sodium chloride is a bad conductor of electricity. Why? Because in solid sodium chloride, ions are present, but ions are unable to move random directions due to strong force of attraction between positively charged ion and negatively charged ion. In fact, that is called ionic bonding. So, because of this strong ionic bonding, they are unable to move, but ions are present. So, that's why solid ionic compounds in solid states which are bad conductors of electricity, whereas in aqueous state or molten state, ionic compounds are good conductors of electricity. What is the reason, my dear students? Due to the presence and movement of ions. And for this movement of ions, solvent is very important. What is that solvent called? Water. Once if you add water to sodium chloride or in fact any ionic compound, water has the ability to dissociate the bond. Whenever bond dissociated, ions become free and they are able to move in random directions and capable to conduct electricity. So for this one activity also there in our textbook for conduction of electricity. So try to follow that. Okay. So this is about today's topic, my dear students. And I even explained about two important molecular formations like ionic compounds from yesterday's module, like what is that? Sodium oxide and calcium oxide. Some of the students may even arise doubts. Okay. And especially this module is meant for properties of ionic compounds. So before going to conclude this class, let me recapitulate this by taking 1 or 2 minutes. Okay. Now, all ionic compounds are crystalline solids with perfect shape and structure. They are hard and they are brittle in nature, easy breakable. Easily they will break when force or pressure applied. And what is the reason why these compounds are hard? That is due to strong force of attraction between oppositely charged particles, positively charged and negatively charged ion. And second point, these compounds, all ionic compounds are having high melting and boiling points due to one reason. What is that reason? A considerable amount of energy required to break the strong inter-ionic force of attraction. That's why these compounds possess high melting and boiling points. Now third one, all ionic compounds are able to dissolve in water because water is a polar solvent. Water has the ability to dissociate the bond due to high dielectric constant. And all ionic compounds are unable to dissolve in kerosene, petrol, benzene, etc. And all ionic compounds are good conductors of electricity in molten or aqueous state. All these are good conductors in, what is that state? Molten or aqueous state. What is the reason why these are good conductors in molten state or aqueous state? Because due to the presence and movement of ions. But in solid state, these are bad conductors. Why? In solid state, ions are present, but they are unable to move due to strong force of attraction. That is called ionic bond. So this is about today's class, my dear students. Tomorrow we shall discuss about one of the very important and interesting topic, occurrence of metals. Till then, girls and boys, have a nice day. Thank you.